Professor Monty, and we're talking about graphing systems of linear inequalities. So we've got two or more linear inequalities going on at the same time. Remember, and I'll link the video where I just show graphing a single linear inequality to the end of this video, but key ideas there. If y is less than or equal or greater than or equal to whatever you have on the right-hand side, it's a solid line because you have the equals, which is the line itself. If y is less than or greater than without the equals, it's a dotted line because the line itself is not going to be part of the solution. If we have y less than or equal to, we're going to shade below the line because the y value that's less than this is below it. And if it's y greater or greater than or equal to, we're going to shade above the line. And we can always check a test point if we would rather do that instead. Okay, so a couple examples. Y greater than x minus 3 and y less than or equal to 1/2 x plus 1. Let's graph each of these. They're both set up as y, so I'm going to graph them using the slope-intercept form. You can plot points if you'd like to. But for instance, my y-intercept here is -3. The slope is 1x, so it's 1 over 1, so I go up 1 and right 1. So there's 2 points on the graph. I'm going to graph that. There's no equal, so it's a dotted line. Also, it's a greater than, so I'm going to shade above the line. And I'm not going to do a big shading, a dark shading, because it's the common shaded region is the answer. So I do know it's up here somewhere, and I'm just going to shade that real lightly. If you're using a pen, it's not as easy to do, but with a pencil, just draw it real light, or just put little arrows pointing up along here. My next line, y is less than or equal to 1/2 x plus 1. I've got a y-intercept of 1. We'll start there. I've got a slope of -1/2, so down 1, right 2. Down 1, right 2. Let's see. So this time I have an equals. It's going to be a solid line. And it's a less than, so I'm going to shade below. So I'm shading this way. And notice this region is only shaded once, so it's not part of my solution to the system, because the system are points that satisfy both. That one's shaded once, it's not part of the answer. That one's not shaded at all, it's not part of the answer. It's just here where they're both shaded. So I'm going to let my teacher know that I know that that's the answer. I'm going to shade it real dark. So that's my solution, is where I shaded 2 times. Now, technically, this part of the line is saying it's part of the solution. Since it's not in the solution region, we really have to dot that. So you'll often see that in books where they dot the line saying, oh, wait, this line's included, but not in that region where it doesn't satisfy the other inequality. So do bear that in mind. That's a little tricky thing you want to look for. Okay, now this one doesn't really look much like what we're used to seeing, but they're saying y is between -2 and 4 equal here. This is actually an and statement. I can rewrite this way. So this one could say y is greater than or equal to -2 and y is less than 4. Well, these, remember, are horizontal lines. So y greater than or equal to -2, I can go down here to -2. Solid line because of the equals. It's above that, so I would shade above that, but it's less than 4. So I can go to 4, draw that line. Oops. There's no equal, so that one's dotted. It's easier for me to do with my whiteboard marker than it would be for you with a pen, of course. But it's everything in between there. And again, I'm going to draw it kind of light because I don't have my other inequality yet. But I know it has to be between, it's in there, it's in that band. But x is also greater than -1. Well, x equals 1 is a vertical line. So I can go to -1. There's x -1. Again, dotted line, there's no equals. Vertical line. It's greater, well, greater than a negative is off to the right. Greater than anything is off to the right for x. And so it's over here, but remember, it's only the common shaded. So it's not up here, it's not up here. It's in this region right here. Let's make that real dark so that we can see it. And we can say that, hey, that's my answer, because that's the dark shaded region. That's the region that satisfies both. Again, technically, we'd have to take that out. So it's this solid line up to that dotted line, but only to the right of -1. And if you wanted to list all these, this is the line x equals -1, this is the line y equals -2, and the line y equals 4. You're definitely welcome to do all that. And if you're on grid paper, it's not as big of a deal. If your teacher wants you to do it, make sure you do. You're trying to maximize your points on these problems. So whatever they want you to do, make sure you do it. But that's the idea of graphing linear inequalities, systems of linear inequalities.